Welcome to week 3 of Python classes. Since you all know that we are in a series of having Python sessions on the weekly basis, where we are trying to learn the ultimate fundamentals required to be proficient in the world of Python programming language. Now, obviously, there is a lot to learn, but our agenda is to learn all those key skills which will help you all to be relevant in the world of AI. So, we started with something very basic in terms of data structures, variables, if else, for loops, conditions, and all that. And in the last one, we went a little bit more complex in terms of complex functions, segmentations, inline functions, whatnot. Now it's time to step up a little bit. And in today's class, we're going to be talking about all related to OOPS programming languages and, classes, objects, attributes, methods, and whatnot. This particular session will help you awaken the concepts of how developers design their own methods or classes to an extent which will allow you to be a really proficient developer. Tomorrow, if you get a chance to work on agentic AI, fine tuning, the world of building your own LLM or building a complex ML model or neural network model, convolution neural network model, neural network, NLP, natural language processing models. So simply running codes in line will not be that proficient. Having an art of building or converting your code more modular going to be really helpful. So with that, let's dive in. We have classes and object today, where we'll talk about attributes, methods, constructors, inheritance, exception handling, and some industry practices in terms of coding. All right. So let's start with a very simple thing. What are classes? Like classes are basically what they capture. Classes focuses on the element of where you are designing a framework that can have some variables, functions part of it. Right? It's a very big module that can do a lot of tasks that you want to predefine. Right? For example, in this case, I have a simple class called vector2d. What it is doing, it has a initializer method in it whose job is to create or initialize variables. It's kind of a constructor, you can say, in terms of classes concept of oops, which runs whenever a class element is declared. So as you can see here, when I will be declaring or initializing an element of the class, as you can see on line number 8, it says v equal to vector2d, which is a class name, and I'm passing two parameters in it, 3 comma 4. So it will automatically kick in this function, which is called method in classes. And because it's an initialization method, it's predefined method, it what it will do, it will fetch the first two variables, x and y, and self, which is kind of a pointer which will point that the value of self dot x will be whatever the user is typing here and whatever the user is typing here. So when I run this cell, what happens? See that type v, the type of the variable is class, and the value of the variable is 3 4, right? So that will help you understand like what does this class means, right? A simple class with a simple initialization method. Now let's make it a little bit more complex, right? Let's have few more attributes, methods, and a class method with the parameter of CLS. So let's talk about all of these things, what it does. So a class is, I have defined name counter. Okay. And you see this, I'm calling that class again and again. One time I'm calling it blank. Second time I'm passing a variable 5. And then third time I'm incrementing, I'm calling a method of that class. Right. So let's take it step by step. This is my class called counter. It has an initialization method which will run every time you declare an element of that class. We already talked about it, right? What it will do, it will initialize the value of the variable with 0, and it will increase its value by 1. Okay, fair enough. And a attribute means a variable shared across the entire class element. Okay, it will initialize not only from a point of view that you have a attribute whose value can be used in the class, but the method is also utilizing that. Okay, fair enough. So if you look at here and in terms of this thing, this is where we are calling it the function that will increment its value. Well, how it is this coming? The increment is coming from this method. This method's job is to set a step. I mean, that is like what by what value you want to increment. Okay, by default its value is 1. So it will step that value, whatever value that you are passing, by that amount, right? Then how many is like how many instances you are running for it, that will be captured through here. Okay, it will take a method cls, that is a variable, right, that we will pass here, and that will help us identify by how many times instance it has been increased. Okay, a static method is something which you cannot make any amendments, it remains static to that environment. Okay, now when I run this cell, what happens? Look at here, what is happening? C1, what is the value of C1? C1 is initialized by the class counter. At that time, it total instance value was 0. Okay, and the value, where is the value? Value is starting from 0. Okay, and the total instance has been increased to 1. So now the value is 0 and the total instance is 1. But if you look at here, we have called increment by 2. So if you increment 0 by 2, what will happen? It will become 2, and that is got printed here. Fair enough. Look at class element 5. I have initialized it with 5. So what it will do, it will override this 0 and initialize its value by 5. Hence, it is coming 5. Right? Meanwhile, I'm printing a value called counter dot how many. This is telling me the value of total instance. Right? So value of total instance will be 2. Why? It initialized 0. Then how many times I have called the variable? 2 times. So 0 plus 1, then again plus 1. So far so good. And the last one is counter is non-negative. What it is doing, it will just check. You cannot make any amendments here. It will do a check. What it will do, so it will not have a self argument. It will just do a conditional check. What it is doing, it is saying whatever variable you are passing, it will return true or false. If the variable that you are passing, if it is greater than 0, it will return true. In our case, we are passing -1, hence it has returned false. So far, so good. Let's make it a little bit more interesting. The next is call your constructors and Dunder methods. Dunder methods means whenever you see these two underscores, that is called your Dunder methods. Alright. Constructors are your ways of initializing the variables. You see, we have already done that. Now we have named it. And Dunder methods is your objective of, wherever you see this 2 underscore, that is what your Dunder objects are. Okay, wherever you see that. Good. So what are we doing? We have a default initializer that will initialize the value of weights and bias. Okay, every time an element is defined. So this will overwrite by default value. 2.5 will replace 1.0 and 1.0 will replace 0. Now the values of these two variable is 2.5 and 1.0. So what is the first method is doing? It is just printing the values that linear model weights are this and this. So I'm calling the first method. Let me run this cell again. It is just printing their values. Fair enough. Then I'm calling the next Dunder method, wherever Dunder means 2 underscores. That becomes the very important inbuilt method of your class. Okay. You see here, there is no Dunder sign. So these are your typical methods of a function class, but these are like your now default element of that class. Okay. It becomes an integral part of your class. All right. Built-in, might have heard the word called built-in functions, right? So now this becomes a built-in function of Python for you. So next one is what it is trying to do. It is trying to print the values of y is equal to this. Y is equal to mx plus c line. So when you will learn linear regression or neural network, you will realize what it is this. Y is equal to mx plus c. And third one is doing this, the calculation. It is multiplying the value by x plus y. So you see, what is the value here? I am passing the value 3 for the your x value, and weight and bias is already defined here. You got it? So what will happen? 3 into 2.5, that is 7.5 plus 1. So 8.5 got your answer. Now, The most important thing, inheritance and polymorphism. This is where your entire Python comes down to. Inheritance means, let's say you're somebody in your organization has already built an amazing package module class, and you need some part of that module. So you will not write the code again. You can leverage the powers from there. Polymorphism means the art of calling that function. I'll tell you both the things in a minute. Okay. So you can see this thing. We have a base class called model. It has a simple method, predict. What it does, it raises an error. It does nothing, it raises an error. You remember in last class we talked about try catch error. It just raises an error. Now, this is my first child class. Why I'm calling it a child class? Because it is inheriting the property of model class. You see this thing? I'm passing a variable here. Now I'm defining a function here, predict. It will return +1. Whatever value I'm pass, +1. Another class, which is also a child class of model, it has a initializer constructor and a function which returns multiplication. It will multiply whatever value it is coming. And then I will call these things. Polymorphism means one after the other. You see the function run inference. It's a function. You remember? Functions. It has nothing to do with these classes. This function's parameter is it takes a model. That means it takes a class as an input and a variable. So the class name is m dot predict for x in xs. Let's see what this will return. I'm calling this function run inference. I'm calling the class, which class I'm calling? Add one. Okay. What it will do? It will initialize this class add one, and it will call the predict function. Now it already has the capability of raising error. In case your function fails, it will raise an error. See, I don't have to write this code again. All right. And then I'm passing 1, 2, 3. See what the output? 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 4. If in your code becomes too big, huge, and there is an error, your code will not be a problem. It will throw a raise error because we are inheriting that property. You see here. Similarly, another function, run inference, I'm calling this time times. It will multiply. 3 ones are 3, 3 twos are 6, 3 threes are 9. This is called polymorphism. Duck typing is, we don't need dot. You see this m dot? No. I can directly call that function. There is a class square. It has a method at predict. I'm directly calling it. See, directly calling the function. I'm not doing m dot. It's the art of writing codes. Okay, this is a polymorphic way of doing it, which requires your duck typing m dot something, and this is something a traditional normal way of calling it. Right? In this, you don't require inheritance. This require inheritance because you have to define which class and which function you are calling. Okay, so we are extending the properties of the existing functions. Then there is a concept of abstract class, which primarily focuses on the fact that there is a template of a method. You are defining a template that if this function is called, what are the static ways of handling that function? Slightly confusing. Let's look at it. Okay, I'm initializing a class called data loader ABC. So you have to pass this ABC, abstract base class. So now what it will do, data loader will become your ultimate class, like the main class, because we had ABC as a parameter. And we have already imputed that this is going to be an abstract base class. Okay. So this will help us understand that a class which has a template of methods in the subclass. What is the method? I'm defining a abstract method that there is going to be a method called load. Okay. Now, using inheritance, we'll extend its property. How will extend? I'm defining another class, CSV loader. It will inherit the properties of data loader and it will have a load function. Now, it is extending the properties. How it is expanding the properties? It will do a read and write. First, it will write some data into that file and then it will read that data. So, if I run this cell, see this file got printed. Not only that, you see this file got created, temp.csv. Because I created that file first and then read the data from there. However, the challenge is, what if you encounter errors during all this process? So error handling is really important. In last class also we studied about error handling in the world of functions. This is error handling in the world of classes. So I have my base class, training error, exception, ABC. All these are your Python inbuilt variables, functions, methods that we are using. Then I'm defining a function train epochs. It does some kind of a calculation if loss is not zero. So, low loss value provided. And it does some functions and calculations. Okay. Now, if this value does not have a value, like not lose value. Okay. Let's say it is true. So not of true becomes false. So it will not run. But let's say this is already false, means there are no values. Then what will happen? No loss value provided. You have to tell someone, right? You see, when you are using your mobile phone, Android, iOS, when you are running complex pandas and all that, you get very good errors, right? Why? Because they have written their codes in this fashion. This is called error handling, right? So when I run this code, let's analyze it. It says safe train. What is safe train? This is function. It takes three values. We are passing a list here. Now try. I will try to calculate its average. Why? Using train epoch. How it is works? Train epochs works like this. If everything is good, it will return sum of values divided by the length of values. So it has returned training okay, average loss is 0.7. Everything went good. But by mistake, one of the developer has passed an empty list. See the error. Training failed. Why it failed? No loss value found. So you see, a good developer will always write their code in a way that you will be able to figure out where that error is. So now I know, right, where this error, I'll go here. Oh, the error is no values were passed. I'll go back and check. Oh, the list is empty. I should have passed some value here. And using that, we have some standard practices. Standard practices means always use standard names like you this say, softmax. I'm telling what this function will do. Pass proper variables, import libraries, write your comments, define your variables properly, do assert means if s is greater than 0, sum of exponentials must be positive. That means if s is negative, this output will come, so that your code does not get dropped. And if you want to take it advanced, there is a package called import logging. It helps you log. You see those crazy good, amazing GitHub libraries which are very popular. They have this thing called logging. Why? When every time you run a code, they are saving that thing in a backend file. So you see when I run this, you see this thing? This is the log. See the Jupyter automatically understood that I'm printing a log. Hence it is coming in a colored format. So makes your coding experience better. Right? I know today's concept was little, complicated. But once you will get these modules, these contents, when you run these codes and you revisit the video again, you will be able to better relate it. And this will really be helpful for you in the long run. Right? So I hope you got something good today. We'll catch up again in the next video. But until then, I'm Jayant Mahara. Thank you very much.